URL and button are working. Yep, it looks like our button is there and it looks like this worked. So congrats, we have our basic add-in with all the boilerplate ready and we can start building our AI assistant. So let's close Revit because we're gonna be rebuilding that layer. And let's go to our command. So we're ready to get rid of these placeholders and start working on our real functionality. So I'm gonna get rid of that task dialog. And what we're gonna do here is start our prompt window, create it, instantiate it, and start it, passing in the data it needs to work. So we're gonna save the application object that is basically represents the Revit UI that is running in the user screen, and we're gonna get that from the external command data. These parameters are passed automatically by Revit when we click on the button. It passes the current context to our execute method here because it implements the iExternal command interface. So we're gonna use this application to access the current document that we have running. So sorry, we can actually get this from the app active UI document. So that's how we are gonna access our current document. And here we need to initialize our prompt window, but we haven't built that yet. So I'm gonna use a placeholder named prompt window that basically instantiates our prompt window object and passes the app and the document objects here. Here we're gonna call the show dialog method. That is a method that every window has in WPF. And yeah, the rest looks good. So now that we have our external command basic implementation, we can go ahead and create the UI. So I'm gonna add a folder inside common called UI, and here we're gonna add a new item, and what we need is WPF window. So it can happen that you don't see it here. We're gonna search for window WPF. Let me see. For some reason, it's not showing up here. Should be user control. Maybe it's because we haven't referenced the stuff we need here. So we're gonna look for system.saml, Windows base, and there we go, presentation core, presentation framework. So let's see if that, yeah. There we go. This is what we need. So we're gonna do the same for the 2024 project. So basically we didn't have references to the WPF basic assemblies. So that's why it wasn't showing up. We need to add this to our two class libraries so that our common code can be built by any of them. And under UI, we're gonna go to new item, and this always happens. Don't worry about it. We're gonna add that to our class library. So WPF user control, and we're gonna go and call this prompt window, and we're gonna do a little trick here. We're gonna move this to our shared project and delete this from here. That's a bit hacky, but sometimes you gotta do what you gotta do, you know. So okay, now that we have our basic prompt window, we're gonna switch this to an actual window. Oh, sorry about that. Window. So this is our basic window. We're gonna make it a bit smaller. So this is gonna be, we're gonna remove this design height parameters, and we're gonna do a hard-coded width of 400 and a hard-coded height of 140. There we go. We want a small window here. Don't worry about that. The SAML files format automatically. And we're gonna add one more flag here, resize mode, no resize. We don't want the user to be able to resize it because we want to keep things simple. And if we allow users to resize, the stuff inside could break. So now that we are inside our window, we have a grid. So inside our grid, we are gonna define a column. And you define it this way. And we're gonna use one star. So we will have two columns. There we go. So those will be proportional to each other. We won't hard code the height because, you know, we don't need specific heights or widths here. Actually widths, because these are columns. So now we're gonna go with the rows, and we're gonna have one row only, because remember, we need an UI with just a text box, a send button for the user to send their prompt, and that will be all placed in the same row. So our height will be, again, one star, and we should be good to go. This grid is mostly if we want to, you know, make the UI a bit more complex in the future. So inside this, we're gonna add a stack panel with a name top stack, and we will add a margin of 10 in all sides. So if we add just a 10, it means it will be 10 all around, so that we don't have anything too close to the edges. Our vertical alignment will be top, and our horizontal alignment will be center. And we're gonna place this in column 0 and grid row 0. And our column span will be 2. We are missing something here. Let me see what could it be. An attribute name is missing. So AWPF. Let me just see what it could be. Add. There we go. Now it's working. So yeah, I just had to add a name and the horizontal and vertical alignments, and I hadn't added the closing tag for my stack panel. But it's not gonna be in this format. Actually, it's gonna be like that because we need to put stuff inside this element. So what we're gonna do here is a text box where the user will input their prompt with a padding of 5, and it's important that we set a name because we're gonna need to access this in the code behind, so that we can get the user prompt and pass it on to our backend function that we already created previously. So this will have a width of 240 and a height of 30. We'll hard code all these values so that things are simple. We're gonna leave a margin of 10 on the right side because we're gonna add a send button there. And the selection opacity will be -2. So we can close our text box there. You can see it's already showing up in our UI. We can tweak the appearance later. And now we're gonna add a button. So our name will be search button. Actually, it's gonna be a send button. Our tooltip will be send execute action. So when the user clicks this, it will tell Zoidberg to execute whatever is in the prompt box. Width is gonna be 50, height is gonna be 30, and we're gonna add a click event. So I just created an event handler by pressing enter. We're gonna close the button. You can see our button is showing up right there. So our stack panel is working. It's stacking our stuff together, but we want this to be side by side, so we're gonna go ahead and fix that. So to do that, we need to change our stack panel orientation because it's stacking vertically by default. So we're gonna do orientation horizontal. There we go. So I'm also gonna do vertical alignment center. so that it gets centered right in the middle of our window here. So now that we have our window here ready and our basic command, we can start with the fun part of actually wiring the functionality here to send the prompts to our backend, receive the code that the backend generates, and execute that in Revit and see how it goes. And then if something fails, restarting that process. So we're gonna go to the code behind. So if you don't see it, just expand this little arrow next to your SAML file. We're gonna see our partial class for our window that is inheriting from user control and extending that class. So this class not only has the methods and constructors and stuff we have here, but also everything inside user control. So remember in our command, we had a new prompt window here. So it's throwing an error because we're not actually importing that part of our code here. So we need to add a using statement. As you can see, this will be in our common.ui. I don't know what's going on here. Just let me check. It looks like that worked, and we're gonna command.ui. Clean this and rebuild. I just want to make sure we need to add Windows-based reference in our project. I renamed the namespace here just to keep things tidy and split everything by folder here. So we're gonna add the missing reference here. Windows base. Actually, we already have Windows base. Let's see. Got it. So our Revit 2024 project is missing Windows base. Cool. So let's retry that. Different base classes. Okay. So sorry about that. We need to use window here because we are using window right there in the SAML. Okay, we are still missing more references, specifically system.saml. We're gonna add that. Looks like most of those references are missing from our 2024 project because we created our SAML file in this one. Okay, now we are actually where we need to be. There we go. Okay, we need to adjust our constructor. So right now we are already using our prompt window class, but it doesn't have a constructor that takes these two arguments. So what we're gonna do here is, like I said, start implementing our functionality. We're ready to do that now. So we're gonna add a few properties to this class so that we can store the document and the application. And we need to add a few using statements here. UI and DV. So we're gonna store our Revit document right here, and our UI app, I'm gonna name it differently than the type, and we're gonna also save our current prompt. So this, I just made this private because we're just gonna use them inside this class. And we're gonna do this in the code behind. I know this is not ideal, but like I said, I wanna keep things simple, so we're not gonna implement any model, view model stuff. We're gonna just do a hacky version of this. So first of all, our constructor is not taking the arguments that we need to set some of the initial properties. So yeah, those suggestions aren't bad. Actually, I'm gonna take those, but here I don't need to pass in a string. I need to pass in a document. So we're gonna sorry about that. Here we go. And actually gonna put this the other way around so that they are in the same order as they are at the top. So we're gonna set these before initializing. So now our constructor is taking the arguments that we need. So we should be good here or not. Okay. It's complaining because we are passing the arguments in a different order. So document app, that's the order we have in our constructor. So we are instantiating our window and we are passing in some basic stuff that we need to work here. So what's this? It's our event handler for our button click. So whenever the user clicks this button, we start the process. So we need to get the prompt the user inputted at that point. So we are gonna save that to our current prompt property. We have our prompt box in our UI, which is this one. Remember, we named it prompt box, so we're accessing the text, whatever text is in the prompt box at that moment. We are accessing that, and here we are gonna start implementing the actual functionality. So we're gonna move this to a different method that I'm gonna call execute Python code, and we are not gonna pass in anything for now. So private void execute Python code is gonna execute the Python code like it says, but we aren't gonna do that in the code behind. We're gonna move that to a different class. That class will take care of handling our code execution. So I'm gonna create a new folder here called handlers, and I'm gonna add a class. This will be a code execution handler. So namespace is common handlers, and I'm gonna using common handlers, we are going to pass in all this stuff to our code execution handler. So here, we're gonna add a constructor, and this constructor is gonna take my application app document doc. Same to and we're gonna add an int max retries. So this will determine how many attempts the system will make before stopping. If it fails, for example, 10 times, we want it to stop, or whatever maximum retries we want it to make. So we are gonna leave that there for now, but right now we're gonna pass in the Revit document. Sorry, let me check. I'm gonna say UI app, Revit document, and we're gonna hard code the max retries for now. So this should be a user input, but we'll leave that for future improvements. Right now we're gonna say it's 10. So this is not the right document class. There we go. This should work now. Okay, there we go. So we are gonna instantiate our handler, and we're gonna add public void okay. Oh, sorry, I'm inside the constructor here, so that explains. So this is our general structure for this class. Basically, we have the constructor and we have an execute method that will start our process. So here we're gonna call the execute method. So this is the implementation for our code behind and our window. We are ready to fully move to the code execution handler. So once we instantiate this, actually, I like to name properties like this in C#. So our max retries, we're gonna save it, and actually we need the prompt as well, the user prompt. So actually I'm gonna add that there, and we are gonna pass in the user prompt there too. So in our constructor, we're gonna map our properties. This is auto-completed by Visual Studio, which is pretty nice. So in our execute method, we are gonna interact with our backend to send the prompt, get the code, and execute it. So for our execute method, we need to initialize a Python runtime in this context in the C# application and Revit context and inject the code that we're receiving from the backend and execute it. So this is where things get interesting. First of all, I'm gonna go to the NuGet package manager again. And I'm gonna look for Python net. So this is the package that we'll be using to interact with Python in the .NET context. So I'm going to install it in our two class libraries right here, and we're going to wait for that to finish. We need to accept some licenses. Okay, good to go. So basically we need to add our using statement here for the Python runtime. Sorry, my remote PC is a bit laggy. So having that, we are going to start by defining our retry count as 0. This is just to kick off the process and to say, hey, we're starting from try 0 and we're gonna increment from there. We're gonna need our assembly. I know we are repeating a lot of code. We have previously accessed the assembly and we're passing in the app and the document as variables in different constructors in different places, and that could be optimized a lot, but we're gonna keep it simple once again. Oh man, sorry. So we're gonna get the current assembly and we need to use system reflection for that. And now we are gonna it's the third time I've done that. Sorry, it's getting late and my keyboard is a bit laggy. So here we're gonna get the path of our current assembly. We need system IO for this. Go path. Get directory name, and we're gonna pass in the. So here we are. If we use the assembly location, we get the entire path, including the DLL file. Here we just need up to the parent directory, and you'll see why in a second. And another component that we're going to use is the Revit Python wrapper by Guy Talarico. So we're going to download that as a library and give it to the AI code as a tool it can access. So we are going to use the assembly path and we're going to append something here. And we need to escape this because there we go. So we are gonna download the Revit Python wrapper Python files, and we're gonna store those in a utils folder in our addin so that we can access them. So that's why we're doing this. We're going to the parent path and accessing a subfolder there called utils that we're gonna create automatically as well. We're gonna get to that in a few. So we are going to now start the Python engine and execute our code. So we need to check if our Python engine isn't initialized. Here negative Boolean. And if it's not, we're gonna execute this code that it's gonna initialize the Python engine. So Python.NET, the library that we're using, requires us to point the runtime to the Python-based DLL that we have installed in our system. So in my case, this is users and my name, app data, local programs, Python, and I'm going to show you here. So going back to app data, local, we're going to go to programs, Python 3.1.2, that is the Python version I have, and this is the DLL we need. If you should have Python installed in your machine. If you don't, you can just go and download and install it. And just note the install path. I think this is the default route. And in there, you should have your Python DLL. So once we locate this, we can pass it to our runtime here. So my Python home will be that path. So I'm gonna paste it in here. This is formatted for the string to escape the backslashes and avoid breaking. So that's why it looks like that. You should do the same with your path. And remember, we have the parent folder here, but we need the actual path to the Python DLL. So we're going to do a path.combine. This is part of the system IO library. And we're going to say Python home. And we're going to add the name of the DLL I just showed you, which is Python 3.1.2.dll. So this is going to build the full path to the Python DLL. So right now we are going to set a few environment variables so that the Python runtime can access this in case we don't have it set up. So this will be called Python home, and we're gonna pass our Python home path right here, and we're gonna target this to the current process. So we're gonna limit the scope of this variable. So we're gonna set another variable for our Python DLL path. So that will be Python net underscore by DLL. And we're going to pass the Python DLL path and target the current process. And now we're going to set it in our runtime. There we go. This is part of the Python net implementation. And now we are ready to initialize our Python engine. So we're going to call the initialize method. So we have successfully initiated our Python engine and set all the environment variables it needs. So right now we are ready to start with the code execution. So we're going to use using statement here using the pygil. And inside that, using statement, we are going to create a Py module. This is just a bunch of stuff we need to do to execute the Python code in the current scope. So we're going to create a Python scope. It's like a virtual environment that will have a set of properties and variables that we defined and that we'll be able to store them as it executes. So the interesting thing here is we can import some Python libraries and pass some objects as variables from our C# code to our Python runtime. So we are going to be passing the UI application and the current document that we have and we see in our screen to the Python runtime to be able to have the Python code execute actions in the Revit application that we have open. Those actions will be defined by the code that the UI gives us, the backend gives us. So it's a very interesting thing that we have going on here. So we're gonna set those variables and libraries that I mentioned. So we're gonna import sys, which is like a system-based Python object. And here we're gonna append to the system scope, the current Python scope, the Revit Python wrapper path. So that's gonna add to the current toolset that the Python code will have everything in the Revit Python wrapper. So we're gonna be able to access some methods and other stuff that the AI could potentially use to be able to perform the user-defined actions. So right now we're gonna set some variables in the current scope that we defined here. Like I said, we're gonna define a variable app and we're gonna pass the UI app, how did I name it? Application. Okay. We're gonna do what I said. We're passing in the current application to the Python context. And the document. And we're gonna also expose it as Revit. Python variables are sometimes called like that. So again, we're gonna pass application. We are not 100% sure how the AI will name those different variables in its code. So we're exposing application in these two ways. If you remember, a while back, while we were doing the backend code, we mentioned in the system prompt to the AI that it would be able to access the current app as app and the current document as doc. So that's why we're setting this here. So right now we need the code that we will execute. So we need to get that from our backend. But we're not going to do that here. We're going to separate that in a different method. So I'm going to name it send prompt to endpoint. And we're going to pass in the prompt that we have stored here in this property. So that method that we haven't written yet is going to return us our code that we need to execute. So we're going to check that that code is actually not null or empty. So we're going to use the string is null or empty method and pass in our code string. So if it's not null or empty, we can actually store that in a different property. Code, it's going to be a string of code basically. So if it's not null or empty, we're gonna say that our code that we have stored is that code. We're going to do that because our code will change dynamically with each retry until our max retries are met. Remember, we are in our first retry here. So if our code is null, we're gonna warn the user with a task dialog. Title will be Zoidberg AI. And we're gonna say failed to retrieve magic from the AI. It was unable to get any code from our backend. So if that doesn't happen, so actually we're gonna return here because there's not much to do if this part fails. So if everything goes well, we're gonna start our retries. So while our retry count is less than our max retries, we're gonna do a try catch block, and our scope is gonna execute with this method our code. After the code runs, we're gonna dispose the current scope because we don't want to say stuff that could potentially harm the next retry if this happens. So we're gonna start from a clean slate every time. And if the code executes, we will just break our loop here. If something fails, we're gonna catch it right here. So I'm gonna do our catch bit, and we're gonna increment our retry count by 1. And here we're gonna say if retry count is, actually we don't need that because I think we might need that. I know it's repeated, but I'm thinking at some cases we could be on our last retry, and no, I don't think we need this. We'll see. We'll see with testing, but we're gonna increment the retry count, and we are gonna ask the backend for new code, and we're gonna tell it what failed previously. So we're gonna modify our prompt saying we're gonna need string interpolation, so I'm gonna do that. So I'm gonna say the user prompt is prompt. The Python code you previously generated failed with the error, and we're gonna send it. Sorry, it's the message. I'm gonna send it the exception that we got, and the current code is, and we're gonna add a couple of new lines here. So that is \n, and we're gonna do code. Couple new lines, and we're gonna say please provide an updated version of the code addressing the error. So in our retry, we're gonna send it the prompt that the user originally said, what failed in the previous retry, what the current code was and ask it to provide a new version of that. I don't know why I say please, but whatever. So once we have that, we are gonna repeat the process. So we're gonna say string new code send prompt to endpoint, and we can send it the prompt text or updated prompt text. Actually, we're gonna reset our prompt property to prompt text here, and we're gonna use the prompt property here so that our prompt property always has the latest prompt and the latest stuff that we are asking from the backend. So this is our new code, and again, we are going to say if the new code is not null or empty, we're gonna save it to our new code property. And again, here we're gonna do if something fails here, we're gonna stop the process and return. So we have our while loop here, and if the retry count is met, we need to stop the process and tell the user, hey, we tried X amount of times and we didn't get to the results. And actually, I made a stupid mistake here. We need a do while loop here, so I'm gonna move this here, and we're gonna say do. So we are gonna be doing all of this stuff as long as our retry count doesn't exceed the max retries that we have set. We have hard coded actually. So now we are ready to move to writing our code to interact with our backend and actually send the prompts to our cloud function and get the code back from it. And we also need to make sure the response is clean. So let's do that. Now let's implement our send prompt to endpoint method here. I'm gonna add this method to this class we're in, our code execution handler class, and I'm gonna use the same one. So this is gonna be a private method that is gonna return a string send prompt to endpoint, and we are going to pass it our prompt text. So here we will need to use an HTTP client to hit our endpoint and wait for the results. So using new HTTP client, we are going to add our header, or remember our API key header, and I'm gonna go to Postman real quick so that I can get the request API key that we were using. Here at the folder level. Sorry about that. I copy that. Go back here. This is not ideal at all in terms of security because we're hard coding our API key, but again, we're keeping it simple for the tutorial. So our base URL here is gonna be, remember our backend project here, it's gonna be our HTTP endpoint. And you can get that either from your Postman window or your trigger tab here in your cloud function. So I'm gonna copy that. I'm gonna send this back elsewhere. And that is gonna be our base URL string. So then we're gonna add our instruction query parameter. So that's gonna be, we're gonna use string interpolation here. Gonna be question mark instruction so that it gets interpreted by our endpoint as a query parameter. So we're gonna escape this string to prevent stuff from breaking, and we're gonna pass it our front text. So our request URL is gonna be our exactly that, our base URL plus our instruction here. And now we're gonna get the response. So we're gonna say var response, and Visual Studio just auto completed that, but basically we're using client get async method there. And we're gonna parse our response as JSON. So there we go, read a string. And now we are gonna deserialize our JSON. And we need to install Newtonsoft, which we are gonna use to manage our JSON stuff. Here it is. This just read my mind. Let's install it to both our projects. I think we're good with the latest stable version. JSON convert. So let's, yeah, there we go. It's gonna suggest us to add the using statement we need, and we're gonna deserialize our response. Actually, I don't think we need to cast that. So our answer will be JSON object dot answer. Remember, we are sending our response as answer here. Let's see what that means. Wait for it to run. So this is a JSON object with a single property called answer, and inside that property we have our Python code to execute the action. Remember, we have some backticks and extra characters here, so we need to make sure to clean that up. We're gonna do that right away. Actually, we are gonna say string code equals clean code snippet, and we're gonna pass it our answer and return code. So this method here takes care of the request, getting the answer, and then passing this to a clean code snippet method that we're gonna implement in a second, and then returning the clean code ready to run in Revit. Our clean code snippet method, we're gonna add it right here in the same class. Yep, exactly that. We're gonna name the parameter code because we're gonna pass it code here. What we are first gonna do is do an array of strings, which is gonna be our lines of code. So we're gonna trim it so that we remove empty spaces in the front and back of our code, and we're gonna split it by \n, which is the new line delimiter, and we're gonna use that so that we can analyze it by line. So if our first line starts with our backticks, as we saw in our Postman response, we're gonna remove that because this is a markdown formatting thing where you can delimitate a block of code and also specify the language of that block of code for syntax highlighting and other stuff. And sometimes these AI models add this to the string just to make it look pretty in web browsers or chatbot contexts. But here we just need code ready to run. So we're gonna remove that first line, and we are going to convert it back to an array. And we're gonna say if lines, we need to do the same for the last line. So we're gonna access the array at the final position -1 so that we can analyze if it has the backticks as well. So this should be the 3 backticks here. We are gonna do the same. We're gonna use the autocomplete feature, and we're gonna only consider the lines up to the latest position -1 so that we filter out the backticks in the end. And in the end, we're gonna create a clean snippet where we're gonna use the new line delimiter that we mentioned. Yeah, the autocomplete is right. We're gonna use the new line to join all the strings in our array into a single string here. And we're gonna be extra careful, and we're gonna clean up some more stuff in our clean snippet. This is a bit hacky, but you know, we are keeping this simple. As I said too many times so far, you're probably tired of hearing that, so I'm gonna avoid clarifying that again. But we are gonna replace several things here. So there are some escaped characters that we need to convert back to their usual versions. They might be returned like this in our web endpoint, but right now we just need the usual characters here. Sorry about that. Put this in here. Gonna unescape the asterisk. We could concatenate all these three places in a single line, but I'm doing this just to keep things more easy to read. And we're gonna return our clean snippet. So we have our clean code snippet method, and this is not angry anymore, and everything's looking fine. So we should be ready to compile this. And remember, thanks to our post builds, we are also copying everything we need for this to run inside Revit. So let's go ahead and open Revit. Not sure if I opened it or not. Maybe I opened it twice. We'll see. We'll find out. There we go. Let's always load Zoidberg. I'm going to use the sample architecture project. Let's see. More to a 3D view. Okay, we have our very ugly window here. Let's try count the windows in this model. See what happens. Okay, something broke, which is not surprising. So let's see what happened. Let's add a breakpoint here and attach our Visual Studio to Revit. It's not catching my breakpoint here. Let's see. There we go. Let's see if we can get it to work, or at least find out what could be going on. I'm going to close the window so we can start fresh. The windows, this model. Let's see if it hits the breakpoint. It should. Okay, we have a problem here. The code is null. That is weird. We need to see. There's probably something failing on our send prompt method. The good thing is we are successfully catching the error, so that's always good. Let's try again and see what's going on with our interaction with the endpoint. So prompt text is okay, count the windows in this model. Let's see if we can move ahead here. Base URL should be that string. Let's see the request URL here. I think I have the problem. Instruction here doesn't have an equal sign. So that's probably breaking. Yeah, bad request. We're getting a bad request from our endpoint. So probably the reason is the missing equal sign there. So I'm gonna go ahead, close Revit. We could use the addin manager to reload, but let's just try closing and reopening. I don't like that, but let's just be quick here. Let's rebuild. Rebuild completed. Let's open Revit again. Always load. Looks like something's happening. There you go. It's alive.